Hey kids, it's nice to meet you. Another day, another new lesson. Are you excited for our newest physics journey? Come on, and let's go on another adventure and learn something amazing. Have you ever seen a bicycle? Have you ever ridden one before? Do you know someone who can ride a bicycle? Chances are you've answered yes. Today, people all around the world use bicycles for everyday transportation, for exercise, and even just for fun. But why would you ride a vehicle that only has two wheels? Only one at the front and one at the back? How is that even possible? Is there magic behind it? Don't be silly. It's just physics. Come on, let me show you. Let's start with the core concepts which lets a bicycle move with only two wheels. Rotational dynamics, also known as torque. We all know that in order to use a bicycle, we need to use its pedals. The pedals provide a force that which we call torque. Rotational motion, also known as rotational kinematics, is the study of rotation as a function of time and frame, disregarding the underlying cause of the rotation. In rotational dynamics, the causes of rotational motion are explored. It introduces the ideas of torque, also known as twisting force, and moment of inertia, also known as mass distribution, and how these affect angular acceleration and etc. If the wheel is not spinning, then the wheel simply slows down. But due to torque, the direction of spinning pushes the wheel to move in the direction of its torque. Uniform circular motion. A cyclist's body movement on a circular track is known as circular motion because it follows a circular path. Therefore, uniform circular motion is the term used to describe the movement of a body in a circular path with constant or uniform speed. This means the velocity doesn't change and the speed remains constant. Centripetal force. A cyclist leans as they travel along a curved path because leaning in the direction of the curve gives them the centripetal force they need to turn. From the cyclist's vertical posture, he must slant towards the center of the circular path. Net force, also known as total force. Zen loves cycling every morning. By pedaling, she applies force to the bicycle, which causes it to accelerate and begin to move. As a result, the force of the bike becomes stronger than the opposing forces of friction from air resistance and the tires of the bike, therefore producing a net force or a sum of all forces on the bicycle. Since the net force is proportional to the object's acceleration, the presence of the net force on the bicycle determines how fast a cyclist is moving. No wonder bicycles are so popular. Balance, or universal gravitation. You don't have to pedal harder to go faster. You just need to understand a little bit more about dynamics, gravitational force, and friction. As we ride our bicycles through the streets, we often take for granted the laws of physics that keep us moving forward. One of the most important of these laws is the law of universal gravitation. This law, first proposed by Isaac Newton in 1687, states that every object in the universe is attracted to every other object in the universe. This is shown in a formula as force is proportional to the product of their masses and inversely proportional to the square of the distance between them. On a bicycle, we experience the force of gravity in two ways. The first is through the weight of the bicycle and the rider, which creates a force pulling them downward towards the center of the earth. The second is through the friction between the tires and the road, which creates a force pushing the bicycle and rider forward. As we pedal our bicycles, we are also creating a force, the force of our pedaling, which propels us forward. This force works against the force of gravity, allowing us to overcome it and move forward. The faster we pedal, the greater the force propelling us forward, and the easier it is to overcome the force of gravity which is pulling us down. But even as we pedal, the force of gravity is still at work, constantly pulling us downward. To maintain our balance, we must constantly adjust the angle of our wheels and the position of our bodies to beat this force. This is why we lean into turns, and why we must pay attention to the road surface and the surroundings. So the next time you're out riding a bicycle, remember the law of universal gravitation and the role it plays in keeping you moving forward. And remember to always stay alert and ride your bike safely. Balance, also known as center of mass. Now, I'm sure you've already learned something from this video, and for the last part of our journey, we're gonna find out how do bikes balance when we ride them. Bikes are held up, at least partly, by two powerful gyroscopes, also known as their wheels. They rotate so fast that it creates forces that make it hard to change its orientation. As a bike wheel spins, it is rotating around an imaginary horizontal line that goes through its center, creating a force in the direction of its spin. If you try to change that horizontal axis by moving left or right, the spin translates that push into a turning motion. While remaining upright may be the primary goal of beginner riders, a bike must lean in order to maintain balance during a turn. The higher the speed or smaller the turn radius, the more lean is required. Balancing a bicycle means controlling the center of mass of the system. In this case, the system is the bicycle and the rider. The center of mass is the point at which all the mass, the person and bicycle combined, can be considered to be concentrated. For the duration of a straight path, the rider must always keep that center of mass over the wheels, or what's called the base of support. A base support is an imaginary polygon that connects the two tires with the ground. Did you enjoy our adventure? I hope you learned a lot. Well, until next time, kids. See ya!
Gusto niyo pa ba ng mga video na nakakataba ng utak? Ano pang hinihintay nyo? Subscribe na!